Hey guys, here is Zeldin once again, and welcome back to my Cryptologic channel. So today we're gonna discuss how to store data using Solidity. For the sake of this video, I prepared a very small and simple contract. As you can see, it's only one page. Now at this point, I do not expect, guys, that you understand every single line of this contract. Don't worry. Bear with me, we're gonna explain every single detail and make it as simple as possible for you. So let's dig deep into it. Before we start, I'll make this full screen. So before we start, I'd like to clarify a very important thing in Solidity and also in every other programming language. Data types. Data types are, think of them as drawers, special drawers where you can put a specific type of information inside of them. So here, for example, I listed some of the famous data types in Solidity. We have the string data type, and it accepts only text. The uint, or unassigned integer, and it accepts only numbers. And the bool, short for boolean, and it holds a value of either a true or false. And finally, the address data type, and it holds the value of an Ethereum address, which, by the way, looks something complicated like this. So yeah, contract video provider. So basically, guys, when you create a contract, you simply write contract and the name of the contract. It's as simple as that. And then you open your quotation and add the code. Yeah, very simple. So what's going on in the video provider contract? Let's imagine, guys, that we have an online video provider which needs to store some user information inside of the blockchain. For the sake of simplicity, let's say it has to store the name, the age, and whether this person is eligible to see 18+ movies, so to say. So how can we achieve this? Now remember, guys, we talked about data types and how to imagine them as drawers. So for this, for completing this requirement, we'll create 3 different drawers, data types, and we'll give them the name of name, age, and age restriction. So the one called name, this will be a string data type. The age will be a uint data type, and the age restriction will be a boolean data type. So what comes next is something called function. Here we have function set user information, and then we have string name uint age, and we have another function called get user information. Now what does this mean? Functions, I'd like you to think of them as machines that take an input, do something, and then give you and deliver an output. So in our case, we have, for example, the set user info, and it takes a string. This string, we have to give it a name. For the sake of this example, I will call it underscore name. So not to confuse with the string name we have. This is only some naming context inside of the function itself. So it takes an input of name and takes an input of unassigned integer age, underscore age. Public, forget about it for now. We'll talk about this in a later video. So what does this function do? It simply says, okay, set the drawer name as the input name you get into this function, and set the age drawer as the input age you get, underscore age, you get into this function. And then if you find that the age is bigger than or equal to 18, then set the age restriction to false, which makes sense. So if this guy is older than 18, then there's no age restriction. Else this means otherwise the age restriction remains true. There will be age restriction. So how to see this in our contract? Let's imagine we have, I'd like you to meet Bob. He's a 40-year-old guy, and our Tommy here, he's a 17-year-old guy. So they are both users of our video provider, online video provider, sorry. So if I add Bob into our smart contract, then we get Bob stored into the name drawer as a name, and 40 will be stored into the age drawer. And after that, after this whole thing inside of the machine, the age restriction will see, aha, he is over 18. Then age restriction is false, and this will be marked as false inside the age restriction boolean drawer. Whereas for our friend Tommy, he gets inside this function, and then the name will be transformed into Tommy, of course. The age will be 17, and the age restriction will be true because he's under 18. So one last thing we need to talk about here is the getUserInfo function. This function has the sole purpose of displaying the user information for us. So in other words, it will display the name, age, and age restriction values that we stored in our input function. So it is written like this. We see here function getUserInfo. Public view, as spoken, forget about it for now. Returns, it means that it returns a value, and this value should be a string, an unassigned integer, and a boolean. And the function itself will return the name that we stored, the age that we stored, and the age restriction value that we stored. So in the case of Tommy here, if we click on the getUserInfo function, we will get Tommy as a name. As an age, we get 17, and age restriction, it will be true. So that's it for this contract. Now let's go and test this code. So for testing this code, I'd like to use the Remix Ethereum Solidity environment. Just to give you guys an idea on how this works. So you simply put here your code, and then go and say start to compile, then go on run. Make sure that JavaScript VM is selected, and then deploy. So here it is, the contract is deployed now. Now I'll make this bigger. And as you can see, guys, this is what we talked about. This is our input function, the setUserInfo. And here I can type Bob, for example. And in the age, I can give here 40. And transact, this means like, submit. So the information has been submitted. And now I should get the information from Bob and an age of 40, and the boolean value, which is the age restriction, is false, of course, because he is over 18. Now if we input Tommy here and put the age of 17, you see we get as a first value Tommy, second value 17, but the boolean here is true. because he is under 18. Now, if we need to store both information about Bob and information about Tommy, in our last example, in other words, in our last contract, this will not be possible. That's why I expanded a little bit on this contract and created the one you see here in the screen. So, what does this mean? So, as you can recall, this is what we had in our last example. This is our friend Bob, and here is Tommy. They are happy, everything is fine. So, what can we do in that case in order to put and store both of them? The answer lays in something called structs. So, a struct is like a, we talked about a drawer. Now it's time to talk about a chest holding a lot of drawers. So think of it as a chest of drawers, and we'd like to give it a name and call it user info, so user information. So as you can see in our contract here, we define the struct by saying struct user info, and this struct would have an unassigned integer of age and a boolean of age restriction. And then instead of applying the name, we do something called mapping. Mapping means that I want to map this name, in our case, for example, Bob. I want to map Bob to a certain age or age restriction value. So Bob will be tied to 40 and not age restricted. See guys, this is how we make it. Whereas Tommy will be bound to 17 as age and Bob as and age restriction as true. Now let's take a closer look on how this works actually. So we have the struct user information, uint age, and the boolean age restriction. This is basically what we talked about earlier. And then we have the mapping. So the mapping is simply telling I want to map a string that I get as an input, in our case, for example, Bob. I want to map Bob to a list, to this user information struct, where it has an age information and an age restriction information. And let's name this mapping all users. So all users will be having a mapping of a string to its user information, or to the struct named user information. In our case here, this will have the following implication on our functions. The setUser function will still get a name in its input and an integer of an age, but instead of referring directly to the age, we have to refer to the mapping itself. So in that case, if I want to import Bob here, then I have to say for all users, the name Bob, please set the information called age inside the user info struct to the input I give here in the instruction, in that case the value of underscore age. The same is also true for the if condition we had. So instead of directly referring to the age, we refer to the age through the mapping. So in our case, here is Bob, this is our string, and it's mapped to the user information inside the all users, and then the user information for this specific string will be age of 40 that we input here, and the calculated age restriction of false, that he is not age restricted. The same is true for Tommy. He also goes inside this, he also gets his own share of chest of drawers, let's say. And then the age information of 17 is stored, and the age restriction will automatically go to true. In that case, I stored both information for Bob and for Tommy. And for this reason, our get user info function looks a little bit different. Because as you can recall, guys, in the get user information function, we didn't have an input. Now we have an input. We have to have an input, because otherwise how will it know if this if you want to see the information for Bob or for Tommy? So in that case, if I put Bob, then please return for me a uint, his uint and boolean, which is stored in the struct. I know this is a little bit confusing for you guys, but let's jump into the remix in order to make this clearer. So, this is my, so this is the remix, in the remix. And then again we go and say start to compile. We got to make sure that it is set on JavaScript VM, and then deploy the contract. Yeah, this looks familiar. We type here Bob and the age of 40, transact. Now we type Tommy and the age of 17 and click on transact. Now as you can see, guys, this is what's new here. The get user information, it has to have an input. In that case, if I type Bob and click on get user info, okay, something went wrong here. Yeah, then it will display for me, yeah, as we told it, an unassigned integer, so the value of 40 in this struct, and the boolean value of false, that he is not age restricted. Whereas when I type Tommy here, I get 17 and as expected a true value of age restriction. So we come to the end of this small tutorial. Let me know, guys, if you found this useful for you, and if you like the idea, if you want me to keep on doing such videos. And thank you for watching.